Audio clear? Little fast. Rain completely stopped. Okay, now we can, no problem, no sound. Everything is okay now. It was raining heavily at 7 o'clock. Now slowly it reduced. Okay. Now, see, yesterday's question. Yesterday's class you lost. See, I never get angry in the class, especially if you tell wrong things all. I told I never get angry. But yesterday was irresponsible from you. It is not the question of telling wrong things. That is without involvement. See, I have shown not last class, previous class only we got Y bar, if you remember. You have not checked it. Or if you checked it, 187.2 you got from where? From bottom. But I noted down somewhere. I didn't see how is the actual way, cross section. See, anything is possible. If I observe correctly, I can make out CG will step slightly, what? It will slightly compare this one now. See, from here 187.2 means from there it will be down. I can make out, but I did not observe it. You did not tell correctly. After everything is over, after I finished everything, then you told distance is wrong. So Y bar, how much you got? 187.20 is from where? Tell me. That Y bar is from where? Top edge or bottom edge? That Y bar, whatever you got, is it from top edge or bottom edge? I'm charging over. See, 187.2 is from where? Top edge or bottom edge? From bottom edge. So, since it is 187.4, see here, this is 30, this is 350, midpoint of web is here, this is the midpoint of web. So, 30 plus half of 350 is 175. 30 plus 175 is 205. From here to center of the web is 205. But Y bar you got 187. So, your neutral axis will come from center of web slightly below or above. Tell the answer. The x-axis axis or neutral axis, will it be slightly below the center of web or above the center? Fast. It will be slightly below the center of web or above center of web. Below. See, last time it was 212, I put above. Anyway, one advantage for you. If it is above, last time while explaining moment of inertia, see, I still wrote there. I told this distance square is 212.8 minus 30 by 2. Look, this side I told. But actually you have to look other side. So, unknowingly, you got to practice when the axis comes slightly above. Actually wrong answer. So, therefore, this is wrong. See, it is wrong. It will be where? It will be somewhere here. From here, little below. This is the axis. This is the neutral axis, or you can call x-axis axis. So, from here to here is 187.20. 20 not required 2. Calculated value. Therefore, from here it will be how much? 212.8. How you got it? From 400 subtract it, 212.8. Now see. So your moment of inertia, now I change it. See correctly once again. Actually not required. Start once again briefly. Anyway, refer last time class. Even if the value is wrong, procedure was correct. Actually, when you find moment of inertia, sometime axis comes below the midpoint here, sometime above. Last time, actually it comes below here. But last time, because of wrong entry, I explained for above. So, you learned that also. See now. Ig plus AH square is for the first one. These all I will not explain. First about its own axis plus area into this distance square. 212.8 minus 10 by 2 square, 20 by 2 square. Or for the bottom one, see, 250 into 30 cube by 12 plus area into from CG to here, this distance square is 187.2 minus 30 by 2 square. But here, see, here, first I about its own axis, 12 into 350 cube by 12 plus area into this distance square. So in last time, I told, look this side. No, you write the last time wrong entry and write whatever I wrote there. Even though it is a wrong calculation, Principle is correct. But now, look this side. I want this distance square. 212.8 minus 20 minus half of 350. That distance square. But actually, moment of inertia answer is correct because, see, last time, everywhere here, wrong values were there. It's interchange. Where 212 is there, last time I wrote 187.2. Where here 187.2 is there, last time because of the interchanging, I wrote 212.8. But when I calculated moment of inertia, I never saw the entry. I never saw the entry there. I directly did earlier class only. So when you find moment of inertia, I don't require these calculations solve. I can directly find it. Therefore, answer is still correct. So one extra decimal I written now. I got the answer. That I correctly came. Tell fast. That I is correct or not? That moment of inertia I. Now go to concept. That I is correct. Little fast. Don't waste time. Moment of inertia about the axis. Did you check it? No. Is it correct or not? After half an hour, you should not tell that is the wrong value. Then again, class will be cancelled for 1 week. If you make a technical mistake or wrong answer, not numerically, checking, still checking. Still checking. What you are doing all these days? Fast, check fast. Because principles are pending. Actually, one class was last week, Friday, it was heavy raining. I think class was not there, beyond my control. It was lightning, like I was stuck outside. I thought if I come before 7:45, start the class. But when the rain stopped, it was already 8 o'clock. Then I left it. 8 if I rush here, 8:15. What is the use? Yesterday class was terminated because of your mistake, not my mistake. Still checking. This much time for checking that one. See, if it is not YouTube class, if it is a class in Zoom, then I would have told you, wrong is okay. Why? Limited people are seeing it. Only people who are in the group will see it. I will tell them, if wrong value is there, proceed further. What is there? Don't check it. But here people are there who will comment that I is wrong. Actually, so far nobody commented that way. Actually, 580 now. How? I got 514. Again you are wasting time. How it is 518? 3 I got confidence in me. 300 into 20. I am not seeing there. 20 cube. 300 into 20 cube divided by 12 plus 300 into 20 into 212.8 minus 10 square plus 12 into 350 cube divided by 12 plus 12 into 350 is the area into 212.8 minus 20 minus 175 square plus 250 into 30 cube divided by 12 plus 250 into 30 into 187.2 minus 15 square. I am getting once again 514.907. 514 I am getting 90713. I don't know what happened. 514 I am getting 907143. Correct? Just check the answer. 514 is correct. 514.90 I am getting 90 now. I don't know why. See, these are all unnecessary waste of time. I don't know any mistake is there now. I got 514.90714. $514.90714. Again 518. What is this one? How you are getting that wrong answer? Calculation is not possible. 12 plus 350. See, unnecessary waste of time. If you are 30 into 187.2 minus 15 close square, I won't leave it. 350 divided by 12 plus 12 I am going to throw this calculator outside. See, you are all wasting time, not doing correctly, not involving. First one, 246. I don't want first one, second one, third one. Do me single answer. That first one, see, now I am calculator is getting wrong. Because when I stand here, sometimes the calculator become problem for me. Again, you are wasting time. See, last time itself you should have done all this one. You should not argue. This is actually got frustrating. Sometimes it happens, calculator, one small wrong button, it gives that way. Again I am calculating. There is a limit for calculation. Sometime I will not leave it till I get the answer. Plus 12 into 350 minus 20 plus 250 into 30 divided by 12 30 into bracket. If this much trouble for moment of inertia means correct 5-1, I am getting 514.90714 once again. 514.137. Now I am getting 514. I am not leaving this one. Sorry. I will not leave this one till I get the correct answer. If it takes 100 years also, I will not leave. I cannot get once here. Again some calculation problem. See, no, you don't know how Kannadalli hata, nimge gottilla hata estiде anta. How much adamant I am. Sometime micromillimeter I will fight. See, now, those who are watching the class will tell time is wasted. 300 into 20 cube. Let me finish. Either I should be there or momentum I should be there. One of them should get repeated now. Cube divided by 12 plus 300 into 20 into 212.8 minus 10 square plus 12 into 350 cube divided by 12 plus 12 into 350 into 212.8 minus 175 again minus 20 that square plus 250 into 30 cube divided by 12 plus 250 into 30 into 187.2 minus 15 square. 514.13. My answer is correct. Some problem here. I don't know what is the problem. I feel like breaking his calculator. Actually, I am used to that other earlier type. This modern calculator, I don't like it. So many functions, after power 3, you have to press one button, I forget sometime. They made unnecessary complication for some calculations. I don't know why they made it. I was using calculator FX100 long back. I never used to commit one mistake also there. Okay. 514.1316, correct. Okay, 10 to the power 6. Limit now. So, I is over. Go further now. See. Now, proceed further. I will remove everything now. See, cross section I am removing. This also I will remove. E1. I will remove everything now. Nothing required. Fresh I will start now. I noted down the values there, somewhere there. Now, start the concept. See, remember this class is for concept, not for any examination like simple question that you study. The real structural concept of bending theory will come now. Start. Now, I will do one thing now. See correctly, I will put a star here. I will not repeat star after today. I will not repeat the star. In future, if difficulty is there, I will tell refer star. Refer the star written for unsymmetrical section. If you know star means some marking. If star mark is there, that means standard it is. So with a color I use blue color. See, write the cross section. No other dimensions required. See, some relative scale. See, we are not interested in exact values. This is part values. Okay, this is the width and depth. Here width is 300, little lesser width here, but depth is more. Okay. Thickness is little more. Okay, no problem. See, this is a cross section. Now, I do not want center of web now. Total is 400. For the total 400, midpoint is 200. But Y bar came from bottom 187. Slightly below midpoint. Okay. Slightly below midpoint. Okay, done. See, now I want this distance and this distance. That's all. This is the neutral axis. This is 212.8 millimeter. Everything is in millimeter. And this is 514. Sorry, what is this one? I am seeing numbers there. It is the moment of inertia. Ayyo. Sometimes what happens is, the moment I put 500, I know it is wrong. Okay. This is how much? This is 187.2. So if I measure here, this is little bigger, Anisha. Yes. See, this is little bigger, not too much bigger. So here, top fiber is little away from this neutral axis than bottom fiber. Now, right here, one statement you write, irrespective of, you should write, remember, I am not writing again. The star is permanent. A total depth, if you want, it is 400. I will mark here. Come here, 400. It is not red color, it is a black, usual color. Why? It is standard. See, you write here, irrespective of whether you find the stress developed due to bending moment or you find moment of resistance, what is MR will come in the class, right there. What is the meaning of MR will come in the class. There are two parts in the bending stress. One is stress developed due to a given bending moment. Comparison. How much you eat, how much you consumed in the hotel, what bill will come. That is, as you eat more and more bill will come. Your money does not count. How much money you have in your pocket does not count there. Or second is moment of resistance. That is how much money you can eat. Your capacity comes there. Or here, how much bending moment, cross section, maximum bending moment, cross section can resist. See, they are different. How much you eat, pay for it. That is the stress due to bending moment. Randomly see. You apply, don't apply bending moment, no stress. Apply light bending moment, small stress. Apply heavy bending moment, heavy stress. Increase the bending moment, stress will become more. It will not bother about material property now. But how much bending moment it can maximum, it can resist. That is strength will come. That is called moment of resistance. You write here. Irrespective, you should write, remember, those who want principle, I am not going to repeat from today onwards. For another one more class, this will continue. I will not tell again and again. See, irrespective of, I told irr means what? Right? 5-6 hours. Irrespective of whether you are finding stresses developed due to given bending moment or you are finding how much bending moment it can resist, that is MR, whatever is that one, the bending stress distribution is like this. See, this is the bending stress distribution across the cross section. Little out of scale because neutral axis comes. I will put correct to scale. If I project here, see, remember now, this is little bigger, see, 212.8, this is little smaller. So, if I draw the bending stress distribution diagram here, this I am removing now. You write that here. Irrespective of all that one, here stress, it will come linear variation to neutral axis, it will come here. See. This is your sigma 1, this is your sigma 2. This will be compression. This will be tension. This is the what I am writing is bending stress distribution across the cross section. Cross section variation is linear. Variation is linear. Already told. Now this is the distribution if BM is sagging. Top compression, bottom tension. Okay. Somewhere here neutral. Okay. Or it can be like this. See, I told you, if BM is hogging, top tension, bottom compression, neutral here, then top tension, I'll mark this side, this way. Sigma 1, here sigma 2. Sigma 1, sigma 2. Again, it will pass through neutral axis. Okay. Little out of scale, okay. Those things all don't bother. Okay, done. This is tension, this is compression. I told you, sigma 1 is maximum compressive stress. Sigma 2 is maximum tensile stress. Don't buy hard that way. Depends upon the nature of bending moment. Or if the BM is hogging, then sigma 1 will become maximum tensile stress. Tensile stress. Sigma 2 is maximum irrespective of sagging or hogging. See, continue further. To get sigma 1 and sigma 2, they are extreme fiber stresses. Extreme fiber stresses. You can either use M by I equal to sigma by Y. Now, this is your Y1, this is your Y2. Or red color, let it be red color. Y1, Y2, red color. M by I equal to sigma by Y. Here. Okay. Or that is sigma equal to M by I into Y. You can use this equation. Or since sigma 1 and sigma 2 are extreme fiber stresses, we can use Z concept. Then I write here, then your sigma 1 equal to M divided by Z1 and sigma 2 equal to M divided by Z2. Comma. Z1 equal to I divided by Y1. Z2 equal to I divided by Y2. Now, for this question, you can use anything. Either that one or this one. Usually, for extreme fiber, this is the most popular. Extreme fiber, Z concept is the most popular. Okay. Now, anyway, for our question, your uppermost distance Y1 equal to 212.8 millimeter and your Y2 equal to 187.2 millimeter and your I about neutral axis is 514.13. How much I wrote just now? I forgot now. Little more accuracy. How much I wrote just now? 514.13. I went for little more accuracy. 1316. Okay. 514.1316. 10 to the power 6 millimeter power 4. Therefore, your Z1 will be I divided by Y1 equal to I. See, here star is there. Statements are common. Numerically, it will change problem to problem. I equal to 514.1316 divided by how much Y1? 218.8. Therefore, your Z1 equal to, check the answer, give me in 10 to the power 6 only. If I give 10 to the power 6, it is most probably 2.41603. Correct? Little more accurately. Z1 is 2. Check the answer. This one. And your Z2. Tomorrow, see, the board will be still open. This I am not removing for entire class now. I by Y2. equal to I. Where is I? 514, 514 point something, 10 to the power 6. 514.1316, 10 to the power 6 divided by y2 is, where is y2? 187.2. Therefore, your Z2 will be, I think, 2.74613, 10 to the power 6. This is in millimeter cube. Remember, moment of inertia is millimeter power 4. Z is millimeter cube. Y linear power 3. I is linear power 4. I or C. When you put sigma equal to m by I into y, m is, for example, Newton millimeter, I is millimeter power 4, y is millimeter, Newton millimeter into millimeter, Newton millimeter square by millimeter power 4, stress will come in Newton per mm square or force per distance square, any unit. Or if I use stress equal to m by z, then m is Newton millimeter, z in millimeter cube, therefore it will again come in Newton per mm square. Why? Here, when you put m by I into y, m is force into distance, y is also distance. That will make it force into distance square. To get force per distance square, denominator should be linear power 4. Here, m by z means numerator is force into distance, force into linear thing. So, to get force Newton per mm square or force per distance square, distance there, linear cube required. That also you can think a little. So, this way you can do it now. This is stress distribution. Now, the most powerful part will come. See, this I am not going to tell. Up sometime, some will come and comment, sir, that part is not clear. If not clear, leave my class, I will tell. How much I explained on that day, why not study? They will come for next class. Then they will tell that concept you told is not clear. Not clear means go back to first class, not here. Bending stress first class and start. Or at least if you are not interested in the derivation, principle when I started study that RCC part or I took some force here, that all leave it, no problem. When I finished that extra information class, RCC part I finished. When I started, now come to real basic or systematic approach. From there start everything and study. Don't come suddenly into a class and tell this is not clear, that is not clear. Clear now? Sometimes you should talk in a threatening way only. Clear now? If not clear, what I am writing now is valid for full bending stress chapter. I am not repeating. What I am writing now, this is for number will change. See, sometimes your y1 may be equal to y2, symmetrical section. That's okay, but all the principle I am telling, clear or not? So, those who want to study thoroughly, they should understand everything. Not come to suddenly a class in between and tell, this is not clear, that is not clear. Okay, now the most powerful, I'll put red color for that one. Most powerful. This is where most powerful. See, once again write. Irrespective of whether you are you should write big letters, whether you are finding stress developed due to bending moment, that is how much money you have to pay because of your random eating, or how much bending moment section can resist, maximum limit, that is called moment of resistance. That is, you before eating you should check how much you can eat. So you should be careful. That is your capacity. Irrespective of that or this one, whatever, remember, your F sigma 1 by sigma 2, see, sigma 1 by sigma 2 should be equal to y1 by y2. y1 by y2. See, that is from similar triangles. See here. Sigma 1 by sigma 2 equal to y1 by y2. Some people write other way. Sigma 1 divided by y1. Okay, that is better. To make it more clear, that is better. See, sigma 1 divided by y1, red color, equal to sigma 2 by y2. Or if you interchange this one, it will become what? Write once again. Or if you interchange, you first write it. Those who are serious will write sigma 1 by y1 equals sigma 2 by y2, or you get your sigma 1 by sigma 2 equal to y1 by y2. Now, y1 and y2 are already fixed. Nobody can change this ratio. See, you write here. This is for a cross section. You write here. For a cross section, the ratio of y1 to y2 is already fixed. Nobody can change it. Whether you find bending moment or stresses due to bending moment or MR, whatever you do, this nobody can change. Or equal to, how much it is? y1 212.8 divided by 187.2. Or, I am removing this one now. See, I want finally answer. Or, you should tell your sigma 1 equal to, tell the answer, 212.8 by 187.2. Number. I want it accuracy. 212.8 divided by 187.2. How much it is? How much it is? Tell the answer. How much it is? 212.8 by 187.2. Number. 212.8 by 187.2. What is the number? This much time to give that number. What you are doing? 1.1367. Do one thing. Fortunately, I have taken first decimal. Why? Because or I can tell it is, see, 1.13675. 675 2 times sigma 2. Or sigma 2 equal to, tell sigma 2 equal to, if you are sigma 2 in terms of, this is sigma 1 in terms of sigma 2, or sigma 2 equal to, how much? Reciprocal of this number. Tell the reciprocal. How much? Reciprocal. 0.8797 times sigma 1. Correct? 0.8797 times sigma 1. Correct answer? Or, fortunately, this number is, see now, if you use the calculator, that number is, this number is 117 by 133. This number is 133 by 117. Check the answer. There's a reason for it. This, if I use second decimal accuracy, calculator may not give it. See, calculator has got a limitation. It may give. Fortunately, very good happened. Our y bar number came 80 something. So I am using it now. Correct? Correct or not? And don't by heart this way. Sigma 1 is more than sigma 2. Don't by heart it. Correct or not? You don't by heart which is more, which is lesser. Sometime, if the nucleus comes too much that side, sigma 2 will be more. You do not by heart which is more, which is lesser. Yes. Or, I will try now, right now, simple language to understand. All I will remove. Or, see, these all you write. Irrespective of whatever you are calculating, see, the stresses developed at extreme fibers, are connected by, if you want to link, sigma 1 equal to, some number I told now, okay, 133 133 by 117 times sigma 1. And or, if you do other way, or sigma, this is sigma 1 in terms of sigma 2, or sigma 2 equal to 117 by 133 sigma 1. See, right here. Now, this relation should be satisfied. Irrespective of whether you are finding stresses due to bending moment or finding moment of resistance. These all you should write. Those who are serious, they should write. If you don't write and see this much only, tomorrow doubt will come. You are only responsible if doubt comes. So, all the statement told by me. So, whether you find stresses developed due to bending moment, I told 100 times now. That is, simply go and eat. How much is the bill? Then your pocket money, your money in the pocket does not count. It is not counted. He will tell that much you consumed, pay this much bill. That much BM you applied, this much stress will come. Or, if you are a safe person, better check how much money you have got before eating. That is, before applying bending moment, you check how much maximum BM cross section can resist. That is called MR. Whatever you do, this is to be strictly to be what? Satisfied. Therefore, you should write here. When sigma 1 is known, automatically sigma 2 is fixed. You write here. Once sigma 1 is, suppose you consider any value of sigma 1, automatically sigma 2 is fixed. Or if you consider any value of sigma 2, automatically sigma 1 is fixed. So you can not vary both of them. Only one of them you can vary. Both you cannot vary. This all clear? First, this is called, see, important equation. The main statement is star. This is called double star. This is called double star. Double connection. See, double star because two stresses are connected. Next time I will tell refer double star. Full clear now? If full clear, I will go further. If full clear, I will go further now. People can't come live. That's the main problem. If they can't come live, see, that's why as soon as the shearing bending test is over, before shear, I may stop YouTube class. I will once again go to Zoom only. Because why? People are watching. Why they can't come live? That much lazy they are. Everybody wants the recording only. That is, if more people are there, I get more feedback. No, people, nowadays, everybody, that same thing, it cannot be corrected. That impossible to correct that present trend of students' attitude. Very bad response. For whatever effort you put, what happens is they think they are almost, everybody is selfish. They want to use the opportunity. They don't think, okay, let me go and attend the class. Let him know that more people are there. At least he may tell little more things. No, that attitude is not there. It will never come. I know it. It is asking for too much. At least those who are coming sincerely work out. So this is called standard. Okay, now start question. Now I don't know, earlier did I give something or not? I do not remember. Okay, do one thing. In the question, did I give a bending moment for you? Tell me. See, question already given. Now write. Question already given. Already given. That is, cross section subjected to, tell me, what BM? Tell me the answer. Some BM I told long back, maybe last week. This question, I told some BM. Tell how much? You should note it down. See, you should have noted down it. 380 kilonewton meter. 380 kilonewton meter. Okay. Sagging or hogging? First, tell me. I don't remember what I told. Sagging or hogging? That also I mentioned. It is important. Sagging or hogging? I told that one at that time. Sagging. Okay. that much sagging is given. Right? Question already given. Cross section subjected to sagging to BM of 380 kilonewton meter sagging. Okay, so bottom tension, top compression, and required to draw bending stress distribution across the cross section. Yes or no? That was the question. Slowly we'll do it. Let this question take 2 more classes, no problem. Let it take 2 more classes. Why? Full chapter concept will be covered in this question. If it takes 2 more classes, also nothing to worry. Correct or not? Question. Subjected to sagging BM of 380 kN meter, draw bending stress distribution diagram was the question. Yes or no? First, yes. Okay, start. Now, solution. Diagram already there. See, they told sagging BM. I'll start here now. Sagging BM. Therefore, tension compression. Your bending stress diagram is this way now. See, therefore, your diagram is like this. Okay, roughly. This is the diagram. This is sigma 1. This is sigma 2. Sigma 1 over compression tension. Start. See, now, if basic used, sigma equal to m by I into y in general. So, sigma 1 equal to m by I into y1 equal to m. See, 380 kN mid. Our values we are substituting in newtons and millimeter. Remember, all substitutions will be in newtons and millimeter. Therefore, that m will become 380 10 to the power 6 Newton millimeter. Okay. So it is 380 10 to the power 6 divided by I, come here. I, where are you? Where is the I? Come here. 514.1316 10 to the power 6 into y becomes y1. So crystal clear here. 212.8. Tell the answer. What is sigma 1 in Newton per mm square? Remember, it is compression. That sigma 1 is maximum compressive stress. It is maximum compressive stress which will be at the top fiber. Why top fiber? Because sagging BM. Okay. And sigma 2 equal to m by I into y2 or equal to m 380 10 to the power 6 divided by 514.1316 10 to the power 6 into y2 is, you can see here, 187.2. This will give you sigma 2 in Newton per mm square, and this is the maximum tensile stress, which will be at bottom fiber. Tell the answer. Third decimal sufficient for me. For me, third decimal sufficient. Sigma 1, 157.283. Sigma 2. Tell the answer. Sigma 2. Fast. This board I am not removing. For tomorrow's class, even for day of tomorrow class, this will still remain as it is. I am not rubbing. This will still remain as it is. Why? I require it. Sigma 2. This much difficulty, you are wasting time. You should give the answer so fast. See, again time wasted. Some escaped there. 1 or 2, those who are present, even they escaped. This escapism, I don't know what to do. If everybody escapes, if nobody is there, I will not continue the question. I will go to next chapter. 138.361. 138.361. Okay. Now, right here. This is using basic. Or make a note. Space is there? Yes. Make a note. Right here. Since These are the extreme fiber stresses. You can directly use Z concept. Z concept. That is what you are using from next question onwards. Z concept. Then directly sigma 1 equal to m by z1, sigma 2 equal to m by z2. M is known, z1 is known. M is known, z2 is known. M 380 10 to the power 6 divided by z1 is 2.141603 10 to the power 6. M2, the M 380 10 to the power 6 divided by z2 2.74613 10 to the power 6. Answer is coming same. It has to come same. How much it is? First one 157.283 Newton per mm square. Second one is 138.361 Newton per mm square. Oh, same answer. What same answer? It has to come same. Same answer coming first. Same answer coming or not? First. No, answer is same or not? Both, it has to come same because both are same. But Z you cannot use for intermediate fiber. Yes, okay, start. Therefore, now, but remember now, make a note. Now onwards, if you want extreme fiber stress, we will not use M by I into Y, we will use directly M by Z. But M by Z, remember, we can use only for extreme fibers. You should not use it for intermediate fiber. Okay, now, therefore, I'll write here now, therefore, see, the bending stress distribution across the cross section, when the cross section is subjected to, so I write here now, therefore, see, bending stress distribution across the cross section, see, when cross section is subjected to a sagging BM of 380 kilonewton meter is as shown below. Is as shown below. How? Write the cross section here, light line. See, light line. Write the cross section here. Systematic means full systematic. This is the neutral axis. Distances you write. You already know it. You write distances. Bending moment is sagging. Top is how much? 157.283 and bottom is little lesser, 138.361. Okay, this is compression, this is tension. All values are in Newton per mm square is the answer. Clear or not? Clear first? Fast. Fast, clear or not? Procedure. Where is the mobile? Procedure clear? This is the bending stress distribution across the cross section. And also, further, they want bending stress at 100 mm from, I think it is 100, I think, correct? Is it correct, 100 mm? I remember 100 only I told, I think. I don't remember now. Did I told 100 mm earlier? Inside? 100 mm or not? I don't remember now. Or you can change the question. I think I told 100 mm. Yes, 100 mm inside. 100 mm inside from extreme fibers. Extreme fibers. That is, if the cross section is here, okay, I will do one thing now. I will come here, this side. I will come this side now. This I can remove. This I can remove now. That is, if the cross section is here, see, this is the neutral axis. I told you, systematic means always systematic. This distance are known for you. How much? 212.8 millimeter, 187.2 millimeter. They want come by 100 mm down here. and here they want to go up by 100 mm. Or if I draw bending stress diagram, see, extreme fibers are this way. Okay, do one thing. This 100 mm level, I'll jump here, I'll put sigma 1 dash. This 100 mm level, I'll put sigma 2 dash. Tell the answer now. Right here. Now note, since, write a note here, since you are finding, see, this is, I written here, since you are finding stresses not extreme fiber, slightly inside, you should not use Z concept. You should not use Z concept. Because why? Z concept to be used only for extreme fiber. So, use the basic equation. Use basic equation. That is, sigma anywhere equal to m by I into y. Y is from neutral axis. Okay, now, to get sigma 1 dash, substitute y equal to, tell the answer. See, somewhere here, y is always from neutral axis. Y is from neutral axis. Tell the answer. To get sigma 1 dash, this stress, I want what is this distance. How much answer? Tell me. How much distance from here to here? Fast. Y distance, how much? How much y distance? It is not 100. 100 from extreme fiber they are given. How much y value? Fast. How much y value are substitute? 112.8 or y equal to, how much here? Y equal to, see, we want our y should be from here up, where is that? Here, this distance we want. This is from 212.8, subtract 100, 112.8, and this distance is from 187.2, subtract 100, 87.2, substitute y equal to 112.8 mm. Tell the answer. Sigma 1 dash equal to 380 10 to the power 6 by I. Where is I? I is 514.1316 10 to the power 6 into y1 is, how much? Y is 112.8. Tell the answer. It comes in Newton per mm square. Answer. It comes in, and since it is in the compression zone, that much compressive. Why? Because it is in the compression zone. Answer. Answer. M by I into Y. You can't use M by Z. Z you are using only for extreme fiber. If you waste time this way, what I can do? See? This much time is wasted, so, and everybody, almost all gone, only 1 or 2 are remaining. Very good. So I decided shear stress I am not doing in, I told earlier only I am not continuing. As soon as bending stress is over, I will stop the YouTube class, shear stress, back to Zoom once again. I do, because why? If it is Zoom, I got a freedom. Why? If I make a mistake, nothing to worry. What mistake? Not technical, print mistake, etc. No problem. And I can talk more naturally. Here I should be careful because it is a universal class. 83.372. Actually, sheer lot of concept is there. The people, they deserve it not to be told. And to get sigma 2 dash, substitute y equal to, how much it is? 87.2. So, sigma 2 dash equal to 380 10 to the power 6 divided by 514.1316 10 to the power 6 into 87.2. What is the answer? Since this is in tension zone, this will be tensile stress. Tensile. It will come in Newton per mm square. How much answer? Sigma 2 dash. 87.2 ಆಯಿತು. 87.2. Okay. 87.2. Okay, over. Or make a note. Just a note. Okay, now all over now. One note you make. This I am removing now. one note. See, objective question, sometimes exam, they will give extreme fiber stress only on one side. They may ask you stress anywhere they want. Can you get it now? See, or you can do one thing. If extreme fiber stress is stresses are already decided, then stress anywhere inside can be directly obtained by similar triangles. Then see here now, this is your sigma 1, this is your sigma 2. Sigma 1 by 212.8 equal to sigma 1 dash by 112.8. You can get sigma 1 dash, or sigma 2 by how much? 187.2 equal to sigma 2 dash by 87.2. You will get sigma 2 dash. You get the same answer. Tell me, clear, sufficient? Clear? Clear means sufficient. Answer will come same. Answer will come same. Clear procedure? No. Now it is too late. Now, sorry. See, again, this is called 64 point. See, how many mistakes you are making now? See, now you are telling wrong value. Okay, correct it. Now I can't do anything. I already rubbed it now. I can't go back. Now you are telling it is different answer. I should stop the class for that one. I told earlier, tell the answer. No, after 10 minutes you are telling it is different answer. This is beyond the limit. See, sigma 1, sigma 2, both are wrong, you are telling. Now you are telling sigma 1, sigma 2, both are wrong. What I can do? For such things, what I can do? I do not want to use the calculator. That's why if more people are there, someone will tell the correct answer. When limited people are there, if they give wrong, nothing can be done. Okay, not my problem. Okay. Procedure clear? Correct it. It's okay, correct. But what happens is, this will be there in the YouTube. Tomorrow there are people who will search for such mistakes. Okay, now do one thing. First you have solved. Now, question continued. Question earlier when I gave the question, I just told, right there. In the beginning, I told, afterwards what you do is, you write the question once again neatly. Earlier I told, draw the bending stress distribution across the cross section and also find bending stresses at 100 mm from what? Outer fiber. Inside of outer fiber. Over. Now, question continued. Now, second question. That was the first question for this one. For this standard question, that is the first requirement. Second question. Now, suppose cross section is subjected to hogging BM. So top is tension, bottom compression of anything. See, last time 380. This time somebody very kind. See, of only 20 kilonewton meter. Someone felt. See, last time somebody was very severe. See now, question. Last time somebody applied 380 kilonewton meter. He ruthlessly, without any what you call is karuna illade, kruri itara. This time the person is a kind-hearted person. He is telling, I am applying a BM of, see, that's all. Sufficient. Why means sufficient? Like last time, you randomly eat. You randomly, everything you ordered in the hotel. This time, silently you told, get me one coffee. That's all. One coffee. Or very hungry, 2 idlis. Last time, this one, that one, this one, that one. Everything. Bill came thousands of rupees. This time, you, due to some reason, you told, give me 2 idlis. Then that's all. Right. 20 kN meter hogging, then Repeat the calculation. Repeat the calculation. That is same question. What do you have to do? Draw the bending stress distribution across the cross section. Decide maximum compressive stress. Decide maximum tensile stress, and tell where they will take place, and also tell what is the stresses at 100 mm inside. Fast answer. See, answer is, now it will come like this. See, it will come like this now. This is your sigma 1, now not compression now. Now it is tension, this is compression. Sigma 2 somewhere here, sigma 1 dash somewhere here, sigma 2 dash. Fast get the answer. Fast get the answer. I'll take just 2-3 minutes break so that I'll continue. Little more time I'll continue. Fast get the answer. Oh, I'll give the answer. You should tell the answer correctly right now only. How much bending moment? 20. Only 8.278 sigma 2. 7.283. This is tension, this is compression, and sigma 1 dash. It 4.388 tension. Other one. 3.392 compression. Now your diagram should come. Top tension, bottom compression, tension, compression, and stresses are given here. Fast get this answer. I will take some 3-4 minutes break. I will come back and give a new concept now. Today only I will give. A new concept I will give today. Then who knows, this question most probably will continue for 2 more classes. Everything I will work out in the available space here. See, everything I will work out in the available space here. See, this side I am not removing. Luckily no class, other class. This much portion I am not removing for tomorrow's class. When I continue, I will work out everything downside. Why? This should be fully visible. Now, after we finish this one, I will give a statement for you. See, I will tell you what we have done so far is bending moment applied without bothering about the strength. First time someone applied this way, 380. Second person applied 20. Sufficient. First time someone randomly, everything he ordered, everything, this one, that one, whatever is there in the menu card, he ordered, full bill he has to pay. High stresses came. This time he ordered just a small item. He was hungry, 2 idli or simply 1 kali dosa, that's all, and paid the bill and came. There heavy spending, here light spending. In both the cases, how much money he is having does not matter. In both the cases, how much money he has got does not matter. Or in both the questions so far, permissible stress never came. Permissible stress never came. Okay, start. Just 4-5 minutes. Because I will come back and continue the question, and 2 more parts I will do today. Because why? Otherwise, this is already known for you. Some concept today I want to cover. Then tomorrow, I think not tomorrow. Tomorrow and day of tomorrow, I will continue same question. See, question will be, I will give different permissible limits. I will ask to find MR if it is sagging BM and hogging BM. Answer is not same. Answer is not same. I will tell you why answer is not same. Okay, start. Don't waste time now. Just tell me all this value came or not. You type all those 4 values. You type came or not. Fast get it. And you solve systematically the way I solved for 380 kN meter. There sagging, here hogging. Here you do rough calculation, but for thorough grip on the subject, you solve it exactly the same way how I solved for first part. System, how will tell? Sir, very easy. Yes, correct. Permanently to remain in the mind. Solve it in the same way. Okay, I'll come in 5 minutes. If you escape, I will cancel the class for 1 more week. Remember, suppose when I come back, suppose those who are, if nobody is there, I will not take any class this week then. Okay. Got the answer correctly? No. Answer came correctly? Answer came or not? See, actually this one question only will completely clear the bending stress chapter. And what I decided now is, including MR in the YouTube, I'll continue. Because why? I can't leave in between. But the continuation of further will be in Zoom only. From next Tuesday, you get the link in the Zoom. I'm stopping this YouTube class. People should learn to at least show the interest. So, got it, okay. So, only because why I can stop right today only and tomorrow I can start Zoom class. No, because it is not justice. I will tell the finer points of MR because why this question I have to go very thoroughly to a thorough understanding subject. So the moment this question is over, there are so many questions are then bending, different sections, variations, all loading problem. In the loading, if given how to find stresses, that's all coming Tuesday onwards. You will continue in the Zoom only. Only those people who are there in the group, they will get it. Others, they won't deserve it. So I decided this week is the last. I am going to stop in YouTube and continue in Zoom. With the regret, I will tell that one. No other way for me. See? Okay, now, see, question continued now. See, third question. I will solve the third question. Fourth question you have to solve in the class. In the comment box, you have to tell answer came. Then only I will stop the class. Third question I will solve now. Fourth question you have to solve. And tomorrow I will tell one important thing for you. What is that third and fourth question? Once again, money matter. See, the money matter very important. Now, see, third question. Remember now, still you never think that sigma 1 is more sigma. Ayo, there's a print mistake here. This is not sigma 1. Ayo, what is this one? Tell me. There's a print mistake here. What is this one? It is not sigma 1. See, what is that one? At least I realized it now. This is not sigma 1. What is this one? I don't know why it happened. This is called print mistake. This is not sigma 1. This is sigma 2. Okay. See, at least I realized it today. Some will comment. He is telling sigma 1 cancels. What is this mathematics? I will tell keep quiet. Don't argue. For such people, I will reply harshly. Okay, now start. Question number 3. Tomorrow I will tell you question 1 and 2 connect to money matter. Question 3 and 4 also I will connect to money matter tomorrow. Next, tomorrow I will continue for special question of strength. See, what bending moment will produce maximum what sagging BM will produce maximum compressive stress of, remember now I am asking you how much you have to eat in the hotel so that bill will reach say 100 rupees. Compressive stress of 100 Newton per mm square. Where I am not telling. Still your money is not counted. Someone is telling. So this is the menu. In the menu, you decided to eat so many things. Up to where if you eat, your bill will come 100 Newton per mm square. Then there is a hotel nearby where cost is slightly either less or more than this hotel. Then I will tell, you stop eating in this hotel, same items, if you eat there, what will be the bill? I will tell you next time tomorrow. Then what will be maximum tensile stress? That is the question. See, still your capacity does not count. What he wants is what sagging BM. See, I will solve it now. Solution. Let M be bending moment, sagging in nature. So bottom tension, top compression, which will produce which will produce maximum compressive stress of 100 Newton per mm square. Now, since BM is sagging, tell me, answer. Since BM is sagging, maximum compressive stress will be where? Tell the answer. Maximum compressive stress will be where? First. Maximum compressive stress will be where? Since the BM is sagging, see, since BM is sagging, maximum compressive stress will be where? Top or bottom? Sigma 2. Baba. Since the BM is sagging, maximum compressive stress is where? Then how you told sigma 2 will be at top fiber. Will be at top fiber. Correct? Will be at top fiber. That is, you have to find what is the value of M for which one, tell me? Sigma 1 or sigma 2? You have to find the value of M for sigma 1 or sigma 2. First. Top fiber stress is what? Sigma 1 or sigma 2? First. Sigma 1 or sigma 2? First. Sigma 1 equal to how much? 100 Newton per mm square. Tell what you do. Use the, now onwards, extreme fiber, use Z concept. What is the formula? M equal to, see, directly, M equal to sigma into Z, or you know, anything you can write. You know that sigma equal to M by Z. So sigma 1 equal to M by Z1. What you do? Substitute sigma 1 equal to 100 Newton per mm square. Tell the value of M fast. Answer. You get 100 equal to M divided by Z1. Where is Z1? 2.41603 10 to the power 6. Therefore, tell the bending moment M in 10 to the power 6 Newton millimeter or in kilonewton meter. Tell the answer. First, bending moment M, which will produce maximum compressive stress of 100 Newton per mm square. Since sagging BM, compression will be at the top. So sigma 1 they are telling 100. Answer M. What BM will produce bending stress in compression maximum of 100 Newton per mm square? Fast answer. This much difficulty. Give the answer in 10 to the power 6. You are wasting lot of time. This much time if you waste, how to take the class? If this much time you are wasting, how to take the class? See? How to take the class? 241, very good. Okay. 241 point, how much? 603. Okay, this ink is problem. Okay. 241.603 or 241.603 kilonewton meter. Okay, now, then they want to find what? Then for that BM, maximum tensile stress is how much? That is, tell me, what you have to find? So, sagging BM, if the compression comes to 100, they want tell tension. Tell what is that one? Tell me. Which one? Which one they want? Sigma 1 or sigma 2? Sigma 1 or sigma 2? First. Sigma 2. That is, they want sigma 2. Only one option. What you can do? Option 1. Sigma 2 equal to M by Z2. Or M. Where is M? M is 241.603 10 to the power 6 by Z2. 2.74613 10 to the power 6. Answer fast. Newton per mm square. Answer. That is tensile stress. Sigma 2 means tensile stress. And then tensile stress for that BM. Maximum tensile stress for that BM. Answer. How much? 241.603 purpose is to get a stress of 100 in the compression. Then sigma 2, it will come little less than 100. 87.979. Or other option, see, we know that sigma 2 equal to, or we know relation between sigma 1 and sigma 2. So once you know sigma 1, you can find sigma 2 by what answer? 117 by, without using bending moment, 133 into sigma 1 is 100. Tell the answer fast. Or you can use the relation here. 117 by 1, that came from where? That came from sigma 1 by y1 equal to sigma 2 by y2. Answer. It should be same. It should be same. Check first. It should be same 87.979 Newton per mm square. Correct? Fast. Yes or no? Yes. Okay. Now I am asking question 4. What sagging BM only I am giving? What sagging BM will produce maximum tensile stress of 100 Newton per mm square? Then what will be maximum compressive stress? Compressive stress. That is the question. You should solve in the same way. In the same way solve it systematically. You have to get the answer now. Now, once again sagging BM. Now they are telling, instead of eating in this hotel, if you eat that hotel, what bill will come and what bill will come in this hotel? See, clear? Money matter clear? First question, if you eat in this hotel, this 2 idli, 1 vada and 1 dosa and coffee, how much bill will come? Then, how much you can eat? If you eat same thing there, what bill will come there? Now, he will go to that hotel first. Question clear or not? Video blur. Okay. Closing stage. I don't know what is the problem. Little blur actually. Okay, you can make 1 minute. I'll go and see there. Anything I can do. Nothing further. Not. Okay. Video is okay. It is okay now. No, later you can see. It is maybe your net problem. Your net problem. It is. You can see later. Now the fourth question is new question. They are asking you what sagging BM only once again will produce maximum tension of 100. Then at that time, what is the compression? I will give answer here. Tell me. Now you have to find M for sigma 1 or sigma 2. Tell me. Now you have to find M based on, now you have to find sigma M based on sigma 1 or sigma 2. Once again sagging BM only. Now you have to find M based on sigma 1 or sigma 2. Fast. Now you have to find M based on sigma 1 or sigma 2. That is audible. No, it's okay. Now tell me. Now you have to find what? M due to for sigma 1 or sigma 2. You answer that much. No. Not. You have to find M for what condition? Last time, compressive stress condition, we found M. Then what is the tensile stress? Now, you have to first find M. M you have to find based on what? Again you are writing meaningless answer. M you have to find how now? You have to find M based on what? Sigma 1 or sigma 2? M due to sigma 2, M considering sigma 2, then what is sigma 1? I will give the answer that M will come, sagging BM will come, sigma 2 is how much? 274.613 kilonewton meter, and then your sigma 1 maximum compression will be 100. Now I got other way. 100 into 117 divided by 133. It is 87.970. You have to get the answer. If you get the answer, type got it. I will close the class. Tomorrow I will continue. If you get this answer, correctly work out. Last time, see, few items if you eat here, or for if you pay 100 rupees, what all you get here. Then, if you go to other hotel, then if you eat that much, how much money you have to pay? Now, other way. If you go to that hotel first, if you eat this much, what all you get for 100 rupees there? Now, then how much money you have to pay in this hotel? If you tell got the answer, first. If you tell got the answer, I will close the class. Tomorrow I will continue. Everything is concept based. These are all clear. You get complete mastery on bending stress chapter. See, this purpose of this example is to give complete mastery or control on bending stress. That's why at last time I stopped the class because of your no cooperation. You have given wrong value of y1, y2. Fully. See, now if you are told, I would have closed the batch only. Now if you tell, no sir, last time your y1, y2 are wrong means, if you tell now, I would have told you, this chapter I am not doing, I will go to next chapter. First. Are you getting the answer or not? Now M will come 274.613 and then sigma 1 will come 87.970. You tell yes, got it, I will close the class. Why? No reply. Video is little blur actually. I will go to advanced 720. Let me see. No, it's okay. Video is clear, nothing to worry. Anyway, there it is clear. You can see recording later. If you got the answer, tell fast, got it or not. This answer you have to get. Tomorrow I will continue other way. Okay. Go through the recording and get the answer. I will close the class. Some net problem. Here there is no problem. Okay. Class is over now. Tomorrow we will continue. No. Display is okay. Nothing to worry. See, when you see the video later, everything will be clear. I am seeing here now. Display is completely okay. There is absolutely no problem. Maybe net problem only there. So later you can watch it. Okay. I goes.